Hola clase. Today we are going through the proof of the formula for the compound angles. Now, to get to the formula, I need to know that the sine and the cosine of an angle are proportions in a right angle triangle, and they also projections in a rotation. Remember, if we place our angle within the goniometric circumference, and we call it alpha, the cosine of alpha is the horizontal projection of that angle in the x-axis, and the sine of alpha is the vertical projection in the y-axis, which means that the cosine of alpha plus beta, an addition of angles, is not going to be the same as cosine of alpha plus cosine of beta, and I will need a formula to actually calculate it. To get to the formula, we also need to know how to calculate the distance between 2 points, our trigonometric identities, of course, and the cosine formula, which we saw last year. Now let's start with our proof to get that formula that we're searching. And before starting, any angle that I defined, alpha, if I place it in the goniometric circumference, it's going to have a set of coordinates, x and y. But at the same time, the x and y coordinates are the cosine and sine of the angle, which means that I can write the point where the vector is landing as cosine of alpha, sine of alpha, instead of x, y. Now, if I use that idea, I'm going to draw an angle A, and the point where that vector created by the angle lands in the goniometric circumference is cosine of A, sine of A. I can do the same with another angle, B, which lands in cosine of B, sine of B. The angle between these two vectors is A minus B, and I want to know how to calculate cosine of A minus B. Now, I know there is a formula to calculate the cosine of an angle inside a triangle. So let's see if I can form a triangle that contains A minus B. If I name this vertex P for point in the origin point, and if I name the other 2 points Q and R and join them, that is actually the side P of a triangle. The other 2 lengths of the triangle are Q and R because we match the points with the naming, and I can substitute in the cosine formula, which in our case is Q squared plus R squared minus P squared over 2RQ. Now, those 2 lengths are a unit each because they are within the goniometric circumference. So I can begin substituting, and I can get Q squared equals 1, R squared equals 1, and 2RQ would be 2 times 1 times 1. So at the end, if I simplify, I have a formula for the cosine of A minus B, 2 minus P squared over 2. But it still depends on that distance, P. So because I have to find that distance, I know how to get the distance between 2 points. Square root of the difference of the x coordinate square plus the difference of the y coordinate square. And since I need P square, I can think that the formula of the distance square equals x1 minus x2 square plus y1 minus y2 square. Remember, we know these coordinates from our circumference, so I can substitute them here to actually get P square. That would equal the cosine of A minus the cosine of B square plus sine of A minus sine of B square. And if I tidy it up, I need to expand. Now I expand from here, I know how to expand the binomial and each bracket, and then I get the cosine square of A minus 2 times cosine A cosine B plus the cosine square of B, that's the first one, plus the sine square of A minus 2 times sine of A sine of B plus the sine square of B. If I tidy up, just to keep the trigonometric reasons of the same angle together. I get the cosine square of A plus sine square of A plus cosine square of B plus sine square of B minus 2 cosine of A cosine of B minus 2 sine of A sine of B. And I begin to see interesting patterns because I know that cosine square of A plus sine square of A is 1, and at the same time cosine square of B plus sine square of B equals 1. Then I see a common factor here as well, so all of these turns into 1 plus 1, 2 minus 2 cosine of A cosine of B plus sine of A sine of B. The reason we did all of this was to actually substitute into the cosine formula. So now that I have it, I can substitute, go into the cosine of A minus B, which originally was 2 minus P squared over 2, and I substitute out of these, 2 minus 2 cosine of A cosine of B plus sine of A sine of B all over 2, and once I expand, I begin to simplify. 2 minus 2 equals 0, cancels, and 2 over 2 equals 1 and cancels. And the result gives me with the formula of the cosine of A minus B, cosine of A times cosine of B plus sine of A sine of B. Now I've got my formula, so I can actually go and use it in exercises. So now it's your turn to go and practice. Thanks for watching.